Hello friends, in this video we will continue our examples on Newton's second law and we will study one more dimension, that is how do you calculate apparent weight inside an elevator, and this we will illustrate using a problem. So this problem says the elevator as shown in the figure is moving down with a deceleration of 2 meters per second square, that is decreasing the speed. So we have an elevator and this elevator is moving in the downward direction and this is experiencing a deceleration and that value is given, that is 2 meters per second square. In other words, this elevator is going to be slow and finally this is going to come into the rest. So this is a decreasing the speed. So magnitude of acceleration is given, that is 2 meters per second square. A 50 kg woman stands on a bathroom scale while riding in the elevator. So she is inside the elevator and there is a bathroom weighing a scale basically, and she rides on this weighing scale. So what is the reading on the scale? So we have to find the reading on this weighing scale. So what are the things that is given in this case? So first thing that is given, that is the mass of woman, that is 50 kg, that is given. And acceleration value is also given, that is 2 meters per second square. And we will see later the direction of this acceleration also. For the time being, the magnitude of acceleration is 2 meters per second square and the mass of woman is 50 kg. And what is my target variable? My target variable is normal reaction, that is Bowman is applying onto this weighing scale. So to further illustrate this, basically when you stand up on any weighing scale, what you do, you try to push this weighing scale. So you are trying to apply the force. So if you consider, let's say this is your weighing scale and you stand up on this weighing scale. So what exactly you are doing? You are trying to push the weighing scale in the downward direction. So you are trying to push this weighing scale in the downward direction. Let's say the amount of this force is N and same force normal reaction is applied by this weighing scale onto you. That is the normal reaction N. And my target is basically to calculate the reading of weighing scale. So what weighing scale will measure? It will simply measure the force or the normal reaction that is applied onto this weighing scale. So basically weighing scale measures the normal reaction and that's why the reading of this weighing scale is normal reaction, and in this case we have to find the normal reaction. But more important point, the Bowman is inside the elevator. So the acceleration of elevator or deceleration of elevator is same as the deceleration or acceleration of the movement. So I can say acceleration or deceleration, in this case magnitude A value is equals to 2 meters per second square, and this is applicable for elevator and this is also applicable for movement. Now how will you solve this problem? So you have the elevator and then what you can do is you can draw the free body diagram on this movement. And then once you have free body diagram, you can apply Newton's second law. So first step is to drawing the free body diagram and then you apply Newton's second law and then you write basically equations. So once you have the equation, you can solve this equation and you can get the normal reaction. In this case, you have only one unknown, that is the normal reaction. You require only one equation. So let us first draw this free body diagram and then we can write equations. So if I consider moments, I can show this moment with a point mass. So there is a force that is acting on this moment in the upward direction, and this force is nothing but normal reaction. With the same amount of force, she is trying to push the ground, or in this case weighing a scale. So the force that is acting in the vertical direction is normal reaction. Her weight is also acting and this will act in the downward direction and magnitude is mg. Now the tricky part about the acceleration. This elevator is going in the downward direction with decreasing the speed. So this means it has a deceleration in the downward direction. So you will have a acceleration of the same amount in the upward direction with a magnitude of 2 meter per second square. So you can write A is equals to 2 meter per second square in the upward direction. In other words, you can say since this elevator is decelerating in the downward direction, it is basically accelerating in the upward direction, and that is the magnitude is 2 meter per second square. Now I know by free body diagram I can apply or I can write equation of motion. So the total forces in the y direction is equals to mass into acceleration in the y direction. So what are the forces that is acting in the y direction? Normal reaction plus mg, but mg is acting in the downward direction. That's why we have to put a minus sign, is equals to mass into acceleration. In this case, acceleration is in the upward direction, that is A. So from here I can calculate normal reaction. So this is nothing but mg plus A. So this is the normal reaction that Bowman will experience, and the same amount of force will be applied to this weighing scale. So let us calculate this normal reaction. Mass of Bowman is given, that is 50 kg, and G value is 9.8 meter per second square, and in this case acceleration is 2 meter per second square. So if you calculate all this will come 590 Newton. Now you can also simply calculate weight of this Bowman. So weight will be nothing but mg. M is 50 kg and G is 9.8 meter per second square. So this will come 490 Newton. Now see, her actual weight is 490 Newton, but this weighing scale or this bathroom scale is showing a reading of 590 Newton. So 100 Newton extra. So this is not her actual weight, the apparent weight, and that's why this is called apparent weight inside this elevator. So she is experiencing extra weight. This is because since she is going in the downward direction and the acceleration is in the upward direction, basically elevator is trying to push her. So she will experience 100 Newton of extra force. So when that elevator is going in the downward direction, this is coming to rest. By decreasing its speed, to decrease the speed, elevator is applying a force in the upward direction. In other words, we can say to have an acceleration in the upward direction, this lift is applying a force in the upward direction, and that's why her apparent weight has increased by 100 Newton. So in this case, apparent weight is 590 Newton, but the actual weight is only 490 Newton, and the increase in weight is due to the fact that this lift is coming to the rest or decelerating, or in other words, it is accelerating in the upward direction. To accelerate in the upward direction, lift has to apply a force, and this force is equals to 100 Newton on this Bowman, and that's why the apparent weight is larger than the actual weight. So I can summarize this fact. In fact, all of you have experienced this. For example, if you are going inside an elevator, so let's say this is a multi-story building, this is the top floor and this is the bottom floor. So if you are coming from top floor to the bottom floor, initially this elevator will start from zero velocity and it will accelerate, its speed increases. At that time you feel light, that is your actual weight is greater than the apparent weight. This means you feel lighter. So in this case, you feel lighter. In this case, velocity is in the downward direction and acceleration basically is also in the downward direction. Now when this is coming to the ground floor or bottom floor, this elevator has to decelerate so that it can finally come into the rest. So this is decelerating. So this is decelerating. In this case, velocity is still in the downward direction, but acceleration is in the upward direction because this is decelerating. So you feel yourself heavy. So in this case, you feel more weight. So you feel yourself heavy in this case. So this is the idea. How do you calculate the apparent weight? The only important point you have to consider the direction of acceleration, and everything is simple. If you are going downward direction and the speed is decreasing, this means decelerating. This means your acceleration is in the upward direction. So you have to show the acceleration in the free body diagram in the upward direction. But if you are going in the downward direction and you are increasing your speed, this means you are accelerating yourself in the downward direction. In that case, you will have a acceleration that is positive. Basically, you will have acceleration in the downward direction. So I hope you like this video, and if you like, then please share with your friends and like and subscribe to this video. I will see you in the next video. Thank you.